all the way back to the beginning of the year. We're starting off with our first topic, which was the International System of Units, or the SI system. SI stands for something in French. Standard International, I think something like that. Okay, shush. So we have the base units here. Meters. I don't know why they have kilograms as the base unit. The base unit for mass is gram. Seconds, amps. We don't need to worry about amps. Not really. Kelvins, also degrees Celsius. We can use those. Moles. We know this one. And luminosity, candela. We don't need to, anyway. Okay, SI derived units or a hybrid unit that uses multiple units: frequency, force, pressure, energy, power, degrees Celsius. There's also density, which is something that we'll talk about in a minute. And the prefixes, okay? You don't need to know tera or giga. We do talk a lot about mega, kilo. Don't worry about hecto or deca. But deci, centi, milli, these are all important. Micro, and then that's as far as you need to go. You'll notice that these are all just regular Roman-based letters, except for this guy, which is the Greek letter mu, micro. Right? So mega is 1 million of something, kilo is 1,000 of something, deci is 1/10, centi is 1/100th, milli is 1/1000th, and micro is 1/1,000,000th. Okay? This rings bells in our heads. Yes. Okay. The bells are ringing. Okay, so now we need to talk about the next topic that we looked at, which is atomic structure. By the way, guys, look at my Ecosia search counter. I just hit 2,500. Nice. Searches. They say that it takes an average of 40 searches to plant one tree. So if I do 2,500 divided by 40, so my searches have planted 62 trees, something like that. Yay, way to go me. Okay, so when we look at atoms, this is the classic representation. Yes, smudgy yellow. Okay, here we go. Protons, neutrons, electrons. The protons and neutrons are contained within a nucleus. What do we know about protons, other than that they are in the nucleus? Neutral, neutrons, yes, they have a neutral charge. Or you could say they have no charge, either way. They have a neutral charge or no charge at all. What do we know about protons? Positive charge. So sometimes neutrons and protons are referred to as nucleons, both of them, because they can be found in the nucleus. So protons have positive charge, neutrons have a neutral charge. What else do we know about them? What? Yeah. What else do we know about nucleons, neutrons and protons? Brendan, what else do we know about nucleons? Nucleons, yes, a term that I just defined. Protons and neutrons. Protons have a positive charge, neutrons have a neutral charge. What else do we know about them?
See, I was really hoping that somehow you didn't say that they are in the center of the nucleus.
They're in the nucleus. Okay. What else? What else do we know? Miguel, what else do we know about nucleons? Oh my gosh, is no one paying attention? Are we supposed to be? Did you just ask that question? Oh my gosh. Why do I even do this job? Why do I even do this job? Guys, my job description is I have to make you know science. And none of you actually want to know science. Why do I even do this? Oh, and we're forced to. Oh, you're forced to. Oh, no. How dare we strive to make it so that you can behave like an adult in society? How dare we? How dare we have the audacity to try and prepare you so that you can think for yourself? Yes, how dare we force you? Yes, protons and neutrons are nucleons. Shelby, I'm not going to insult you, but you really set me up, like really, really well right there. But I'm not going to do it. Okay. So, nucleons, neutrons, protons. They have mass. They have mass. That is very important. Does anyone recall what kind of mass they have? What kind of unit we use to measure their mass? It's three letters. An AMU. What does AMU stand for? Atomic mass unit. Thank you, Leighton. Atomic mass units. We use atomic mass units to measure the mass of protons and neutrons. How much mass in AMUs does a proton have? This is not a hard question. How much mass in atomic mass units does a proton have? One. You said it, but you did not say it very confidently. One.
I can still say, just because I'm not 100% sure that anyone know, because
okay.
One would be when I'm clicking a test, okay?
One would be where I would click on text.
We only learn for tests.
All right, shush. Protons have a mass of 1 atomic mass unit. What about neutrons? What is their mass? They do have the same, Leighton. 1 atomic mass unit. The number of protons determines what about an atom? Its element. Thank you, Leighton. Its element. So let's count these up. 1, 2, 3, 4, 5, 6. Assuming that we can see all protons in here, there are 6. What atom is this? What element is this? Brendan? It is carbon, number 6. Yep. Okay. 6 protons. How many neutrons do we have? 1, 2, 3, 4, 5, 6. So what is the mass of this element?
12.
12.
There we go. Brain's working.
Okay. So this is carbon 12, C12. Carbon 12, meaning that it has 6 protons, it's carbon, and it has a mass of 12, meaning it has an additional 6 neutrons, giving it a total mass of 12. What if I had 8 neutrons? What would its mass be if I had 8 neutrons? Yeah. 14. Good. 14, which would be an isotope of carbon. an isotope of carbon, right? So carbon has two major isotopes, carbon 12 and carbon 14. One has 6 protons, 6 neutrons. The other has 6 protons and 8 neutrons. Okay? So you can determine an isotope, the element, as well as charge, looking at just an atom. How many neutrons, or sorry, we have 6 and 6, right, in the nucleus. How many electrons do we have? 1, 2, 3, 4, 5, 6, 7, 8. We have 8 electrons, 6 neutrons, 6 protons. What is the charge of this atom? Yeah. -2, which means it is a what? An ion. Okay, an ion. Specifically, a certain type of ion, which I'm not going to ask because I feel like it will follow up with a long, drawn-out silence that is awkward for everyone.
Is it a negative ion?
It is a negative ion. Negative ions have a special name. An anion. No, it's an anion.
Oh.
Anion. A-N-I-O-N. Anion. Or, again, I don't know why they named it that and why we pronounce it that way, but I feel like it should be pronounced anion, but it's not. It is an anion. Does anyone remember what a positively charged ion is called? Cation. Or cation. Cation. C-A-T-I-O-N. Cation. Okay? Positively charged is a cat, negatively charged is an an. All right? That is atomic structure. Now, if we check out our good old pal, the periodic table of the elements. The periodic table is your best friend when it comes to chemistry. Okay? Your best friend when it comes to chemistry. When we look at the periodic table, it has, first of all, the atomic number, which is 1 for hydrogen, which is the number of protons, right? We also have included in here the average atomic mass, right? So this tells us that lithium, most lithium atoms have, all of lithium atoms have 3 protons. What does the average lithium atom have for number of neutrons? 4. I couldn't see your hand, it was behind Franklin's. Yeah. 6.94 would indicate that the majority of lithium atoms have a mass of 7, right? So that means that they have 4 neutrons to go along with their 3 protons, okay? We can also see this. What is this? This 2-1 situation. 2-5, yep. This is the electrons in their shells. We have 2 electrons in the first shell, 5 electrons in the second shell. Remember, what is this column called here? The noble gases. What is a noble gas, Miguel? Miguel? What is a noble gas? They do not react with things. Correct. Question is, why don't they react with things? They have all 8 valence electrons. They don't need anybody else's electrons. They are good to go. Yes, we're going to talk about that in just a second. The periodic table also shows us quite a bit more, okay? Depending on where the elements are on the periodic table, we can infer certain characteristics, right? Electronegativity, which is the thing that Leighton was just bringing up. Electronegativity means the amount that an element wants something. What is the thing that the element wants that has high electronegativity? Electrons. Yep. It wants electrons. Does anyone recall which element has the highest electronegativity? Fluorine. Very good, Jay. Fluorine has the highest electronegativity. In fact, we can go and look at properties, isotopes. What?
I made a chlorine gas in my house.
You made chlorine gas in your house? Why did you do that?
It was an accident.
Don't do that. Okay, fluorine is the most electronegative. These over here are the least electronegative. Why is it they are the least electronegative? Because they're nerds. Okay. What? Why is electronegativity so low over here? They have less electrons. Look at all these electrons, dude. 36, 46. They want to give them away. Thank you, Jay. Everything in this column wants to give away electrons. Specifically, this one. Right? Because the shell underneath it has a full valence. It's full. So it can pretend. Potassium here can give away its one electron and pretend that it is argon. Okay? Okay? Potassium can give away its one electron in its outermost shell and pretend that it is argon. Remember that everything is all about cosplaying as a noble gas. That's why they want to give their electron away. And that is why fluorine and chlorine want an extra electron so bad. Because fluorine wants to be neon. And chlorine wants to be argon.
Wait, you go back to electronegativity. You said, I thought the noble gases did.
They generally do not react. Krypton and xenon are a little bit different. They're a little bit weird. What they want to do is they want to put electrons in their lower shells for quantum chemistry reasons that I'm not going to get into. But you can see that helium, neon, and argon are completely whited out because they don't have any electronegativity at all. Okay? Good question. Okay, we can also look at atomic radius. What is atomic radius? Franklin, what is atomic radius?
Atomic radius is like it's how it's organized, right?
Nope.
It is the distance from the nucleus to the outermost electron.
It is the distance from the nucleus to the outermost electron. Somebody has their notes and is paying attention. Thank you, Jay. The distance between the nucleus and the outermost electron, it is the size of the atom. Does anyone recall which atom is the largest and which atom is the smallest?
helium is the smallest and francium is the biggest.
Correct. Francium is the biggest. Helium is the smallest. As you get closer to this side over here, the nucleus of each individual atom pulls in with greater force on the electrons, making these the smallest of the atoms, and these over here are the biggest. Kind of. Atomic radius is the distance between the nucleus and the outermost electron.
So the farther to the left, the more like dense.
Well, the farther to the left, actually, they spread out more. The electrons spread out.
Oh, right, yeah, because francium is bigger.
Francium is the biggest. Helium is the smallest.
Okay.
Cool. Okay, so we can look at these periodic trends. So you can see here we have very small, and here is very big. Small to big. Okay? Okay. We can also use the periodic table to tell us what kinds of bonds will be formed between different elements. So what are our three major types of atomic bonding? We talked about two of them, and then we talked about one of them much later. Jay? Covalent and ionic, yep, those are the two major ones. And then way, way later than that, we talked about metallic bonding. Okay? Metallic bonding, covalent bonding, ionic bonding. Davis,
Yes.
what kind of bond would you expect to occur between a sodium atom and a chlorine atom? You will tell me in just a second.
Between a
Chlorine and sodium. What do we know about these guys? What do we know about sodium in terms of its electrons?
would it be an ionic bond?
It is an ionic bond. Why?
Because the sodium has too many electrons and the chlorine doesn't have enough, so it needs to steal from sodium.
Perfect. Yes. Sodium wants to give away this electron. Chlorine really wants this number to be 8. And so the chlorine steals the electron from the sodium, and we get a ionic bond. Yep, sure is. Salt.
Two things that only doesn't.
Magnesium and oxygen. Magnesium and oxygen also enjoy bonding together because magnesium has 2 electrons that it wants to get rid of, and oxygen wants to gain 2 more electrons. So they create what is called a double ionic bond. Right? Okay. Now, if we have an oxygen and an oxygen, let's say an oxygen wants to bond to another oxygen. What kind of bond will occur here? What kind of bond between ionic, covalent, and metallic would occur here? It would be covalent. Why would it be covalent? Because they are sharing electrons. Anything that is bonded together, anything here in this area, so if fluorine bonds to another fluorine, it will be a covalent bond. Oxygen bonded to another oxygen will be a covalent bond. Oxygen bonded to a fluorine will be a covalent bond.
Oh, it's not just, wait, you said that area, you're talking about the green or like the?
Just like this whole area right here. Okay? And then anything that is in the middle here, these transition metals, form metallic bonds. Why are these, what are metallic bonds and why do these transition metals make them? Because they're metallic, yeah.
I really don't have anything on the typology other than it's elemental communism.
Elemental communism. That's all that you need to know. What does that mean?
It means everyone gets an equal split.
They share electrons. Electrons are free to roam in between the atoms.
Like communism in theory or communism in practice like the sun?
Communism in theory, let's just say that. Okay, they just share everything. Okay? Communal living. Okay. What?
You know what?
Communal living.
Oh, I heard not that.
You heard not that. Okay. All right, I'm going to end this video here. I got to take a break.